So in last class of variable mass system, we were discussing about the how we can calculate the thrust force for a variable mass system, which is having no external force. The total force on the body or the variable mass system are zero. In that case, we did learn that the thrust force is equals to minus of V relative into dm by dt. This was the formula of thrust force that we derived in the last class. If you do not know, so please watch the last video of variable mass system. Now in this second video of variable mass system, we are going to learn about the case in which the total external force on the variable mass system is not zero. In this case, second case, the total external force on the variable mass is not zero. So let's take the example. So we are assuming that this is a rocket and that is going under the influence of gravity. So gravity is the external force that is acting in downward direction, and because the mass of this rocket will continuously decrease, and the fuel fuel will be going from outside from the this downside in the down direction. So that's why the thrust force will be acting in upward direction. So now from here, if we take, let's say, we assume that the initial mass of rocket at t is equals to 0 is m naught. Let's say the initial velocity of rocket is u. Now at time t, we are assuming that the velocity is v, and the mass, because continuously mass is going out, so mass at time t is m naught, and we are assuming the rate of decrease of mass is r. So after time t, the mass will be m naught minus rt. Okay, now we can form the equation. So from the Newton's law, we can say that total force on the body, total force is equals to mass into acceleration. Okay, so here there are two forces that are acting on this body. One is thrust force, and thrust force we know it is minus V relative into dm by dt. And another force is mg. Now it is acting in downward direction. That's why we are taking minus mg is equals to minus m into a. A can be written down dv by dt. Now what we do, we multiply this equation with a dt and write down this term to the right side. So we can write down this equation v relative into dm minus that will be going in right direction, so equals to m into dv minus that will be becoming positive, so mg into dt. Now we can take out the m common, and we can write down here in the denominator. So v relative into dm divided by m is equals to m multiplied, sorry, that m is now not here. Okay, so dv plus gdt. Let's integrate it. So we are going to integrate this equation. So mass is changing from m naught to m naught minus RT, and the velocity is changing from u to v, and time is changing from 0 to t. Now here v relative is constant and g is constant. So when we do the integration, so let me write down over here. Okay. So dm by m, that can be written as log m. So minus v relative into ln m, and the limit will be from m naught to m naught minus RT. And when we integrate this dv from dv, it will become v, and the limit will be from u to v. And when we integrate g, g is constant, and dt, when we integrate, it will become t, and when we put the limit, it will become gt. Okay. So now from here, if we write down the this right side, in the left side, we can write it down as v minus u when we put the limit. So v minus u plus gt is equals to minus v relative, and here it can be written down as ln m naught minus RT minus ln m naught. Now ln A minus ln B can be written down ln A by B. So I am directly writing it down as ln bracket m naught minus RT. Uh, so let me clear it in the next step. So this is m naught minus RT divided by m naught. Okay. So V can be written down as, when we take it the right side, so V is equals to U plus GT. Okay. And it will no longer plus, it will become negative, right? So it will be minus, so U minus GT. And when we write down ln A by B, we can write it also down as minus of ln B by A. So, and minus minus will become positive. So V relative multiplied by ln m naught divided by m naught minus RT. Okay, that is the equation that we are getting. And this is the equation where we are considering the external force, and in this particular situation we are considering the external force as gravity. There can be another external force, like there can be air drag force, there can also be another external force, but in this case we are taking as gravity. So that's why we are getting this term. If there would have been any other force, then we could have integrated from over here. So now this is the velocity equation. If you want to find out the acceleration at any time t, we can find out from this equation or this equation. Here from this equation we can find out the at any point of time we can find out how much is the uh, acceleration. Okay. So in this lecture today we understood that how in the case of a variable mass system and external forces, how we can find out the thrust force at the total force and the velocity. Okay, so now you can go and try the questions, and if you are watching this video just for curiosity, so thank you very much. You can continue on learning the physics aspects, although it may not be your course. So let's end over here. Thank you very much.